All right, this is day 2 of working with our slope. We did notes yesterday, and let's see if we can make sense of this. Now, where we're heading eventually is that we can take these equations, looking at them in this form, and without a data table, we can immediately graph these. Now, we're not there yet, so let's take a look instead, and let's start here using a data table. So, this data table is going to get graphed here. And then we're going to see how this graph makes sense that that's the equation of the line. And this is actually a proportional relationship, one that we've done already. So let's go back through it. It says graph the ordered pairs in the table below. Let's graph these up here. So the x goes first. Go ahead. You're going to use these as notes. I'd like you to keep them in your math notebooks. Here's my x and my y-axis. Let's remember that the x comes first, -1, -4. So it goes like this. -1 going to the left, -4 going down. 1, 2, 3, 4. And I get this dot right here. That's -1, -4. The next dot shows that it's at a 0, 0. That's the origin, right? Right in the middle. 0, 0 means we don't go anywhere. Here's my next dot. And then finally we're going to graph this. 1, 4. +1 goes this way. 4 up, 1, 2, 3, 4. And this is just graphing ordered pairs, something you've done for years. And I'm going to go ahead and, just so we can see this clear, I'm going to go ahead and graph this from the line. Okay? This is the graph of that line. And it actually has the equation y equals 4x. And let's look about this. It's asking the question, what is the pattern of the y values? And so y means how far are we going up each time, right? And I can count this. The pattern of the y value is that it's going up 1, 2, 3, 4 every time from dot to dot, and goes up again 1, 2, 3, 4. This y value is going up 4 squares each time. And what is the x doing? Well, I go up 4 and I go over 1, and this is this triangle that I'd like you to draw, because all of our slopes come from a triangle, and they're going up 4 and over 1, and this is a repeating pattern that happens over and over again. Up 4 and over 1. So what is the pattern of the x value? We would say that value is 1. And so then we go to what's the slope, and we've been doing this, right? The slope is your independent variable, or your dependent variable is first the y-axis, so it's 4 over 1, not 1 over 4. And now we're using, we talked about yesterday, we used to use the letter k for a constant, but now we're using m to represent the slope, n, and it's the 4 over 1. We ask, can we simplify that? No, but we can write, if something's over 1, we can always write that it's just 4. So let's go take a look at this, and this is a little different because it has this +1. And we're going to let down so you can see. It has this +1 in it in this equation, right? This one doesn't have anything after it because it goes to the 0, but what will this +1 mean on the graph? So let's graph these real quick. We got -3, 0 is my first ordered pair, right? Right here. -3 goes to the left. 1, 2, 3, 0 stays there. So my first dot is here. The next dot, the x doesn't move, 0, and we go up 1. So I got 0, 1. That's the second dot, 0, 1. Third dot, 3, 2. So notice we always are going to the origin before we're starting. So I got 3, 2. I start here at the origin, and I count over 1, 2, 3, and then up to 1, 2. Negative numbers go down, positive numbers go up. And already I can see this pattern. Like, I can tell you where the 6, 3 is going to do. Let's go do this pattern already, these triangles that we're going to draw, right? Look at this. I'm going up 1 and over 3. There's the triangle. There's my slope, up 1 over 3. And notice how this repeats. So draw that next triangle, right? Up 1 over 3. Well, what's the next one going to do? It's also going to go up 1 over 3. And we're going to see that lands up where that 6, 3 is. up 1 and over 3. And sure enough, that dot is the 6, 3. Is the 1, 2, 3, 4, 5, 6. 1, 2, 3. That dot is the 6, 3. So we've graphed these ordered pairs, and we see after drawing these triangles, the dependent variable first, the y-axis over the x-axis, 1 over 3. And we can see that our slope, I'm going to skip ahead down here, that our slope is 1 over 3. Not 3 over 1. Remember, it's not the bigger number that's on top. What number's on top? It's that number on the y-axis, my dependent variable, that vertical, is the number on top, not the bigger number. Sometimes it's not. And so the pattern that we saw on the y values went up by 1. And the x values, they went going up by 3. So it's interesting. I'm not going to tell you. I'm going to let you figure it out. But where do you suppose this 1 came from in our equation? We got our slope here, right? This is our slope, is 1/3. But where'd that other 1 come from? Where does that show up in here? Let's do this last one. Now notice here is going to be a negative slope, right? So we already know with this negative slope, this graph is going to be pointing down, right? And when we graph these ordered pairs, we're going to see that this line is moving down. Let's take a look at it. Okay, so we got negative 4, 5. Always start at the origin. Negative goes to the left. 1, 2, 3, 4, and then positive up. 1, 2, 3, 4, 5. So starting way up here with that first ordered pair, negative 4, 5. And so we can see this is going to come down in this direction, negative slope. Now we have a negative 2, positive 2. Start at the origin. Negative, go to the left. 2, positive up. 2, and then land here. And already here you can draw a triangle. We can see this pattern. So even before now I do these next 2 dots, let's get comfortable with this triangle that we see, right? What did we do? Well, we went down and over, and here was my triangle. And this triangle will repeat over and over again. How far did we go down? 3. How far did we go over? 2. So I'm going to jump ahead down on here on our again, and like, what is the slope? Well, it's down 3 over 2. The 3's on top because that's my dependent variable. And let's go ahead and repeat this. Down 3, 1, 2, 3, and over 2. And there's where the next dot should be if we did this right. Hopefully we did. It went down 3 and over 2 again, right? Let's check. This dot is that 0, negative 1. Well, 0's here, negative 1. And the next dot, let's graph it and then see if the triangle works out. 2, negative 4. Start at the 0, go 1, 2, and negative 4, 1, 2, 3, 4. Down here, is that going to work? Is that giving the same triangle, down 3 over 2? It better, or we did something wrong. Down 3, yeah, it's working. Over 2, we have another triangle. This is that concept of that repeated slope that we see, that we spot these triangles between any 2 dots. The pattern in the y value was it went down 3, and in the x value it went over 2. And I wouldn't worry so much about your positives, negatives here, because we know this slope has to be negative. No matter what, no matter which one, whether I had negative 3, positive 2, or positive 3, negative 2, it's still going to come out the same. Our triangle had 3 squares and 2 squares, and it's negative. Why? Because the slope is moving down in the left to right direction. So why don't you write for me now, what do you notice about the slope and function of this equation? Just look at these graphs and just write down things that you notice, and especially if you can figure out where do you suppose these numbers are coming from. because that'll come in our next lesson, and I'm just interested if you could see where that's coming from. Now, we'll flip our page over, and it's the same thing again, and you could do this on your own, but I wanted to give you like a heads up. What is this looking like? What are we doing? All right? Okay. Thank you. Have fun with this.